Okay, virtual firewalls or multiple context mode is going to be our next topic. So this is another of the mode settings you can enable on the ASA. And one, as we discussed, was to select the routed versus transparent mode. There is also a mode you can select for single versus virtual context. So virtual context, when enabled, this feature allows you to use a single physical firewall to create multiple virtual firewalls. So this is basically enabling virtualization on the ASA, where each of those contexts or virtual firewalls can be configured with its own policy, a set of interfaces, and resources. So when the feature is enabled using the mode multiple command, which is gonna require a reboot of the device, you're gonna end up in the so-called system context, which is a representation of the physical device itself. This is where you will be allocating the interfaces to the contexts. This is where you will be creating the contexts and also possibly setting up limits for the resources. You can also potentially change of the physical settings on the interfaces, such as the port speed or duplex setting. This is all what you can do in the system context. And then another context we will be dealing with when running the multiple mode is the admin context, where admin context is basically like any regular context, but it allows you to manage the ASA. So the regular context, this is what represents a virtual firewall. And this is gonna be that device that someone is going to be configuring with its own set of policies and rules. This can be either a separate department, or maybe for large companies, or maybe for ISPs. This can be basically a separate customer. This is when this feature is typically used, when you want to provide different policies for different parts of the network, or maybe just different customers. Now, versus the admin context is going to be also regular context, but as I mentioned, it allows you to configure to access the ASA for management. So when you connect to the, using some kind of remote method, when you connect to the regular context, you will be only able to configure this individual context and no other context. You will not be able to access the admin context, the system context. You will be only able to configure the context you have connected to. Versus what is going to be different when you connect to the admin context is that you will be able to access the system execution space and also any other single context. So by default, if you want to access the system execution space, you have to use a console session. You have to connect for the console table, because this is going to be the only way you can access it. Now, versus if you want to access the system execution space remotely, you have to first configure an admin context and connect to this admin context. Well, admin context is actually also used for a couple of different functions. This is where you will be enabling the configuration for some configuration that is going to affect the firewall itself. Like you may configure logging for the system context, also the interfaces allocated to the admin context, and they're going to be used to communicate for communication for the features you have enabled for the system context, such as NTP server. Maybe you want to enable AAA for the admin context, and also some certain logging settings. So this stuff is going to be, whenever the interfaces are supposed to be used, or just you will be trying to access some servers that are located off the local network, the admin context interfaces will be used to access those. Well, obviously each of the user contexts, it has its own set of interfaces, and the functions you enable for those contexts, and the services, they will be reachable for those interfaces that are part of that particular context. So I can have my AAA server defined in context A. I can have a AAA server defined in context B, those servers will be kind of like independent from each other because they are defined in the different contexts. So they're only related to the customer or just to the department that is being represented by the virtual that belongs to the for which the virtual firewall was configured. Now the advantages is that, as I mentioned, you can have just a single physical firewall with multiple different policies configured on different contexts. The disadvantages are somewhat similar to what we saw in the transparent mode. You cannot run any kind of routing protocols. You cannot use VPNs, QoS, and also multicast is not supported. Now, what we saw in the transparent mode was that we were at least able to bridge a multicast frames for the ASA. In the multiple context mode, this is not possible unless you're running multiple context in the transparent firewall. But what I'm trying to tell you here is that there may be some certain situations that you will be supposed to pass multicast packets through the ASA, like with GetVPNs and Rekeying being configured as the transport for, multicast being configured as the transport for Rekeying messages. Then, if you are running the single multiple mode, this would basically mean that you cannot pass those multicast packets, and you cannot, and since the ASA cannot participate in the multicast routing because you're running the multiple mode, this would basically mean that the only way you could forward those packets for the ASA would be to use some sort of tunneling technique. And typically this is going to be a jury tunnel. So this is something you want to remember about when you're running multiple context in the single mode. There is going to be a problem with multicast, and the solution is going to be to use that GRE tunnel. Okay, now let's talk about traffic classification, which is an important concept related to the multiple mode. So in the multiple mode, multiple context mode, what you can do is you can basically allocate a single interface or maybe sub-interface to more than one context. And this is then going to mean that this particular port is going to be a shared interface. And there is a problem related to the classification whenever you're using shared interfaces, because this interface is going to be represented with a single MAC address in those contexts you have allocated it for. And this is going to cause problems for in the data plane. So if I wanted to visualize that, assuming that we have configured our ASA with two contexts, and we have allocated a single interface on the outside. So this is going to be that interface that is shared. This is outside. We are actually using two contexts. We have defined two contexts on this single ASA. Context, let's say A, with its inside interface, and context B with another physical interface allocated as inside. But as I mentioned, the interface on the outside is shared. Now the problem we run into here is that, well, actually this interface is going to be configured with different layer 3 information. So let's say that A is going to be using 10 on the outside, and B is going to be using 20. But when you think about this setup here, when router 1 wants to send a packet to a server that is a part of the context A, well, it is obviously going to have a route in its routing table that says to get to this guy, I will be sending packet to that IP address. Now the problem here is that if we had another server, let's say FTP, at layer 3 everything looks good. But the problem we run into here is that when the router is actually trying to do the actual resolution. So it is going to be trying to figure out what is the corresponding address, a layer 2 address. I will be sending the packets physically to get to this guy versus that guy. And as I mentioned, shared interfaces, they also share a single MAC address. So both contexts are going to be using the same MAC, which is, let's say, M. And router 1, that when the ASA gets the packet, which is destined to M at layer 2, it basically doesn't know if the packet should be sent to this context or maybe that context, because the packet is physically sent to a single MAC. So the solution to this problem is a traffic classification which can be done in two different ways. One way is going to be to use the unique MAC addresses, and the other one is going to be to use a network address translation. So with this first method, unique MAC addresses, what we can do on the ASA, we can globally, in the system context mode, we can enable a so-called generation of unique MAC addresses. There is one command, a global command called MAC address addo, which is actually now in the newer versions of code. It is a default setting, which is gonna force the ASA to generate a unique MAC address for any interface that is shared between the contexts. So this is gonna mean that in our case, A is gonna get a MAC, let's say M1, versus B is gonna get MAC 2. Now when router 1 wants to talk to this guy here, it is gonna be sending the frames to M1, versus if it wants to send a frame to this next hop, it is gonna be sending the packets to this MAC. And since those MAC addresses are unique between the contexts, the ASA will actually know where the frame should be sent to. So this is the first method. You can also enable and configure individual ports with unique MAC addresses manually without using this MAC address addo command. You'd basically have to go to the interface that is shared in a context, and on the interface outside, in context A, you would have to say that the MAC address is this one, using the MAC address command at the interface level, versus for B, you would change the context, you would go to the interface outside and say that you want to assign that MAC address. So this is the first method, the first solution to this problem. Now another method is going to be to use, as I mentioned, a network address translation. So we're going to have the same topology here, and just one ASA and two contexts, A and B. But this time, MAC address is going to be still the same in both. So for some reasons, maybe they restricted us in the question. We are no longer allowed, we are not allowed to change MAC addresses on the shared interface. But we still want to enable the packets to flow for the ASA in a correct way. So the way we can fix this with NAT is by using unique translations. And There is actually no way, when you share an interface in the multiple context, there is actually no way to create translations that will overlap, because the firewall itself will not allow you to do that. It has an internal mechanism. It does some internal checking whenever you want to add a translation, and it will basically not allow you to add a translation that overlaps between the contexts. So with this method, you will be basically configuring that for the individual devices you want to be reachable for the context. This is going to be our FTP and web servers in this case. You may create a translation for the whole subnet. Typically, this is going to be static translation. But the logic here is that once the translation is done, let's say that we are using 10.1.1 on the outside, and this is going to be 192.168.1/24. And this subnet is going to be 192.168, let's say 2/24. And the translation is going to be, this guy is using that, let's say that 5, and this guy is using that 25 in the subnet, and we say we want to translate that 5 to that 5 in this network, versus this one I want to change to be 10.1.1.25. So now the logic is that since the translations are unique between the contexts, when router 1 sends a packet to this address, the ASA gets the packet, and it knows that this translation is associated with this context, so the frame is going to be sent to context B. Versus if the packet is sent to this address on the outside, it matches the XLate in the net table of context A, and because of that, the frame is going to be sent to context A. Okay, and one more feature related to the multiple context configuration you may want to enable is called resource limits. So, and the problem with virtualization is that you're actually sharing, all of the resources, or all of the physical resources available on the unit, on the device, are being shared between all of the contexts. So connections, XLates, whatever the ASA is physically capable of handling, this is all shared between the different contexts, and you typically don't want to have a situation when a single context is gonna use, like, let's say 95% of resources, leaving 5% for anyone else, or whatever else may be the numbers. You just want to make sure that a single context does not oversubscribe the firewall. Not only oversubscribe, but also it doesn't prevent other contexts from getting the resources for them. So this is where you could use this feature, which is enabled by the class command. You will basically create a name for the class. So this is going to be like a class of resources where you will specify the limits, either as a percentage value of what's physically available on the ASA, or maybe as an absolute value, such as 50 telnet sessions, management sessions to the context, and then you will assign this class to the context. Now, all different settings, all different resources that are not defined in your class, and they will be inherited from a so-called class default, which is by default assigned to all contexts. So all contexts are initially part of this class default, which only restricts the management sessions to 5 for telnet, SSH, and ASDN. So on the command line, this is gonna look like an example here. We're gonna define our class, specify the limits, and then in the context configuration, now we'll basically say that this context is supposed to be member of that class, which is like you're associating the class with the context. And all of the settings, all of the resources that you haven't specifically explicitly configured in the class, they're going to be inherited from the class default, which once again by default only limits the telnet, SSH, and ASDN sessions, management sessions to the context.